we've got a huge range within what the members make, and a lot of elements of this is products that have been consistent, stayed around, that are kind of fit for purpose. You know, concrete pipes, concrete manholes, they are ubiquitous, they're utilitarian. We have members that make bespoke products even within that category. One of the things that's most interesting about what our members have done is the innovation element of it, you know, but from preform manholes and then systems around that are all sort of, you know, they're all hidden away, but there's very clever bits of technology that have moved on. Again, one of the things we need to understand is how much that off-site element has decarbonized the industry as well, because, you know, this is knock-on benefits of that. When we're doing things in factory conditions, we're making things a lot more efficiency than has to be on site. So there's all those different pieces. There's, you know, you talked about like ovoid pipes. Again, another solution to where we have climate challenges. Ovoid pipes are very specifically designed to deal with a lot of flow. Like you said about capacity in these things, we need big pipes. We can't just keep sticking bigger and bigger pipes there. We need to have smart pipes, smarter systems, and things like ovoids, you know, which will deal with high flows, but then they'll deal with low flows and not clog systems up. There's tons of products within industry like that. You know, everything our members make, from the top of a chamber of seating rings all the way down to big, massive box culvert, they all have very specific uses, and again, iteratively down the years have become sort of fit for purpose. It's the bit where we then keep iterating those products that's going to be really, really interesting. That part of the you know, the research work with the MPA is focusing more on those products and iteratively improving the design of them.
And Pete, from your perspective as well, I imagine that Marshalls there's constant innovation as well, constantly looking at new ways in which to tackle the changing problems.
Yeah, there's always two ways of doing it. It's always a challenge, because unless you know the problem, it's hard to come up with a solution. But then you often don't know what the problem is until you find a solution. We invest heavily in new product development, but actually when we think of commodity products as pipes, manholes, they've stayed the same. We know what we're doing with those. It's how then we work with the sort of whole treatment train, and we're working with partners to look at systems where they've got very innovative systems, but actually, funny enough, they need a good structure around them, and that's where you know, a nice concrete chamber actually works really well. But yeah, it's about working along that whole treatment train, and from when that water hits that roof, how can we get involved in those longer processes, permeable paving, you know. So, and then the worst case, which funny enough is a big concrete tank at the bottom, but there are cases that it's needed. So.
Well, I suspect it's not just the product, is it? It's also the installation method and how those two go hand in hand. So if you have a product that is really difficult to install, then it makes it a bit more challenging, but also if you can think of a different installation method, that might impact your product. So yeah, they go hand in hand.
And that's a real interesting shift in the industry, where we look at value. It's not just pounds and pence of the product, it's the pounds and pence, it's the social value, it's the installation methods, it's all that wider message of value and what that brings.
It's utilization of products as well. It's not just, so Faye touched on it, an element there where we talked about what the additional parts of an EPD might look like, what extra bits are in there, you know, what happens when you're using certain materials, what's the knock-on part of that. We talk about it wider in sort of industry. You know, you said about carbon value, you know, timber materials, you know, considered to have no carbon at the port. You know, we challenge bits like that, because there's clearly lines in which we want to poke into and try and understand whether there's truths in it, or whether we need to account this an awful lot better. You know, microplastics have been a huge element of the conversations you and I have been having, but that comes from other materials as well. It's not just us, you know, how our materials are used, it's how other materials are used, and how did that whole site look. Yeah, we know our challenges. We, as we said earlier, we've been very honest about some of the challenges we've got in using our materials. It's understanding if that's the best fit, and where we absolutely advocate that is the best fit for it.
And also understanding that we're not always the best fit, and having that openness to say that actually, you know, there are systems out there that might do this job a little bit better, but then I suppose it's a mix of green and grey and different greys, I suppose, different shades. There's a spectrum there of different systems and solutions.
We've got some not so smart clients in the UK, and you can understand that they're presented with an array of products: plastic products, concrete products, sustainable drainage products, completely natural processes and nature-based solutions. But then they don't inform themselves well enough often, so they'll be cajoled or hoodwinked by contractors, and they'll end up with the wrong products in the wrong location. And that, trying to make our clients smarter and more informed would be a brilliant step forward. But they're untouchable. I've tried really hard to reach clients, and they don't want to talk to me.
It is interesting though, because tier one contractors, they are really getting on board, because they've got shareholders that are talking about environmental impact. You know, they've really got targets to hit, and they are really driving that conversation between the clients and the suppliers to push both sides really to work harder. So it is, to actually defend a tier one contractor, they are actually working hard at the moment.
And what we need is that due diligence. So when a product manufacturer makes a claim about pollution removal, we need the contractors and the clients to say, well, come on, show us your certificate, because that's not happening enough. And we're in a position now with AMP8 and this massive leap forward in the marketplace that if we're not careful, people will come into the marketplace with spurious claims about their products, and then we'll regret that.
Is that tough enough to crack? Though you mentioned obviously tier one contractors, obviously they've got the sort of the depth and the bandwidth and the resources to deal with that. You know, we have this time and time again with product clients as well, is actually tapping into the tier twos and the tier threes that might be a little bit less willing to part with, you know, the resource that they have, or the, you know, given margins so small as well. Is it about really trying to like get into them?
Yeah, I guess so, but also the tender processes are getting a lot more difficult for those tier twos, tier threes to get on those sites, because if they haven't got the credentials, they're not getting on that site. So it is happening across the whole industry where they've all got to get on board with it, because they just won't win the jobs. It is the wider effect of that. It's not that bottom line price so much, it's all the credentials that they can offer. So
I think built within those credentials is a lot about, as Joe said, like, you know, you can end up with these sometimes overclaim of what materials can perform to. I mean, this is one of the most interesting parts of working with, with universities. Our products have always been declared to be certain performance. It's one of the things we've always kind of hung our hat on, to be fair. On the material advocacy side of things, everything the members say performs to a certain thing, does what it does. But what's interesting is how those standards can be worked to be, I'm going to say, less conservative. You know, we've always had this headache, and I'm going to say we here for concrete and masonry and precast side of things, we've always had this headache where we are sometimes over-designing. In fact, a lot of the cases over-designing for resilience, which has borne good fruit in that we've got systems that will last almost assuredly beyond their design life. But I mean, you will have seen this a lot more than myself. You know, you've written a lot of these standards and understood. There's definitely efficiencies I think we can make moving forward that will have a huge knock-on effect for us.
Yeah, for sure. I mean, there are some simple concepts of design and buried structures which have already commented have persisted for about 120 years, but they're very one-dimensional. And there needs to be a bit of a change of thinking that even rigid pipes, even concrete pipes, are only a component of the structure. The ground around them is all part of it, and the hole created in the ground once you buried a concrete pipe is a very valuable asset. So all those things we want to preserve. But I'll just give one example of the language that's used. In the concrete industry in this country, well, in the English-speaking world, we talk about a crushing strength. When you squeeze a concrete pipe between plates in the factory, it's a crushing strength. But that has led to some extraordinary knock-on effects. It's a very one-dimensional view, and amazingly, you know, even eminent consultants out there, they do their numerical analysis and they try and compare the vertical load they're predicting with the crushing strength in the when in fact what's happening, and we really ought to change the language, it's not a crushing strength, it's a ring bending strength, and it's the bending moments in the concrete. And the other thing is that for sure the way in which pipes are designed tend to be over-conservative, because the so-called bedding factors, these magic numbers that tell you how the performance in the lab is supposed to relate to the field, are based on sort of case scenarios, which is right. But a lot of the design methods and the derivation of those, for example, ignores the fact that concrete pipes crack. People think, well, you don't want your pipe to crack. But actually, when a pipe cracks in the ground, its interaction with the ground around it changes in some ways beneficially. And so when tests are done, it'll be interesting to see what the MDF results show. First of all, you don't tend to get cracks in the places you expect them. And secondly, you realize that your rather simple theories aren't necessarily borne out in practice. We come back to the point, we've got to observe what actually happens. And what could be the consequence of that? Well, it may be that the manufacturers also have to change some design concepts. I know it's been stated here, it's a very well-established thing, but for example, where you put the reinforcement in the pipe, if you anticipate it cracking, do you make sure that it's still got sufficient cover, that it doesn't corrode, and all these sorts of things? I think with more experimental evidence, the opportunities for actually smart design, not just of installation, but also of the products, I think could increase.
As I say, microplastic generation on construction sites. Particularly when you are cutting concrete, there are lots of health and safety rules about dampening, so you're not breathing in things. There are lots of rules about what can and can't go, water needs to be treated. They're not in place at the moment for the plastics. So when you cut plastic pipes, you will be generating microplastics. How many are you breathing in? Should you be having dampening? Should you be wearing a mask? There's just nothing out there really on that. How many of those are going into the ground? What happens to them once they're in the ground? Because there is no waste management process for them. They are literally just left there and swept to the side and left to run off. So the project that we're looking at is going to construction sites, hopefully some that your members may allow us to come and look. Initially, we'll be looking at all of the plastic on a home construction site, understanding where the sources could be, and then specifically looking at actually getting some numerical numbers for what are the number of microplastics being generated during cutting, how many cuts are happening, and multiplying that up across a 10 house, 100 house, 1,000 houses, or whatever that is. So that you can understand exactly what's going into the environment, as opposed to there being sort of different rules for different materials. Some traditional ones, that health and safety has already been done, and some of the newer ones, there still needs to be work done on that.
And I imagine there's also, as much as there's the professional risk on site, especially for people, I'd love to say that everyone wears their PPE on site properly, but we know that's not the case. But is there also that public risk as well? Because I imagine a lot of those particles can be carried on the wind as well. Let's say you were walking past a development where the site was going on. You could be I was watching that brilliant From a Toxic Town the other day about when they were redeveloping after the steelworks, all of the cadmium dust that they're taking, they didn't cover up properly, and it created lots of birth defects, so on and so forth. And I imagine there's this, with microplastics, there could be a similar ticking time bomb as well for, say, just the general public.
Yes, so obviously I won't say too much about the health implications, because we don't have that information yet as a group. We know that there are implications for many other species, and so it's very unlikely that there will be no impact on humans. It's about understanding thresholds, and the more we're putting out there, if it doesn't break down for 200 years and we're constantly adding more and more, those thresholds will be reached at some point. So it's understanding what those thresholds are. And as you say, when it comes to air doesn't stay in one place. Air moves around. There are a huge proportion of microplastics in the air. In fact, we're more likely to be breathing them in than we are eating them from fish. But that's a public perception, understanding that it's in the fish. So yes, there is a possibility. There's also just that understanding, particularly if you've done a beautiful job in drainage, and you've got this lovely pond at the end, and you've got a swale and it's all green. What does it mean if you've got loads of microplastics in the soil? The likelihood is the soil health is worse, the worms suffer, and therefore the quality of the planting and things. If you've got your veg patch, etc., it's unlikely the number's going to be so high to cause you problems, but you will be contributing to your microplastic burden if what's in the soil from those cutting processes gets into your food source.
Also from a manufacturing base, I think this is one of the things we don't touch on enough. That the whole industry, especially our industry where we've got significantly large bits of concrete, we've got these big products that we work with at the works, we cut them, we make them into other pieces. Like the health and safety part where you talked about, talking about cutting, years ago we were challenged with reducing dust, reducing airborne issues. Years ago we were challenged with and put everything in place to make sure that that element becomes much safer. We've got great controls on those because we cannot afford to let that element become an issue for us long term. Again, we don't want to build up that process where we're just raising, materials, raising airborne problems and challenge that, not just out on the field, not just out when you're installing, it's at works as well. Manufacturing processes have had to get a lot smarter over the years about that.
And then, Steve, do you want to have a little chat about some of the other things? Obviously we've covered a bit about MBIF works at the moment as well. We can maybe go into a bit more detail about that. Talk about standards as well. We've already obviously covered the microplastics. Do you want to give us a bit of a flavour about all the great stuff you guys are doing?
We, the MPA, on behalf of the members, we've got people here, we've got this great product lineup. The reason we advocate for it is because we like the material. In and of itself, we advocate it because we think it's the best material. As somebody said, there's always lots of choice, there's always other materials out there you can work with, and certain ones fit for certain things. For us, things like the research is incredibly interesting, but there's other parts. There's things like we produced handling videos, just things that can make things safer. Construction is a big industry. It's a dangerous industry when you don't do it right. Stuff that we do can have knock-on effects. It can have environmental impacts, but it also can have human impacts. Parts of the EPD that we talked about, other issues that come off that can have localized human impacts. All that comes together in very complicated ways. There's always like 2 or 3 sides to any one part of it. The product side of it, we think we know where we are. We're measuring with EPDs. We're doing research to try and help everything. It's understanding where we can improve parts of that, where the members have got products that can come in. Some of the innovation within there is stuff. Even myself working in the industry, I wouldn't have seen coming. Because we've got brilliant people in there. We've got people innovating, producing not just the products that have been there forever and a day, it's the next step on. That's what's really interesting. Decarbonisation, product innovation, and what the members have got coming next is phenomenal for myself to look at.
And tell us a bit more about the highways talk as well, because that.
Oh yes, for sure. I mean, we will.
I know someone else would like to have a bit of a final closing statement about highways as well.
So
You go first, Steve.
No, we we were very fortunate last year at UK Highway Show to be asked to go and give a talk. We did a little bit of we did kind of a soft launch. We talked a little bit about some of the work we've done with the MBIF, how we can innovate some of the standards, which can have really good knock-on effects for the whole industry. Our products are where they need them to be. We can help the industry further down the line. This year, we are hoping that with some of the more practical input testing that we're doing with Birmingham University, we're looking to talk a lot about how we're trying to help that industry, again, like practical results in a not pun way, have some concrete results that we can then present off of the back of and sort of bring some of that innovation to the wider industry. Highways is a great one. Highways is able to change where it needs to. It's got its own standards. It's not reliant on BS per se. It's got its own works that it can twist onto and work to if it wants to. So we can give them pieces that, on behalf of members, that can then help them with their projects.
And Joe, you had one of the points that you wanted to raise was around sort of issues with the highways and particularly runoff, wasn't it?
Yeah, so the large part of my work is dealing with pollution from highway runoff, and the products are available. And as Steve has mentioned, this industry has products available. Other industries have products available to treat highway runoff, and nature-based solutions can treat highway runoff in a large part. The difficulty at the moment is getting the money available to invest in that treatment, but also when National Highways have money, but getting them to invest in treatment is really difficult despite already having money. So we've got a massive gap. So we've talked about emissions control and carbon reduction, and and all those other control mechanisms. But the massive gap at the moment in the UK is treatment of highway runoff. It just isn't happening to the extent that it must happen. And yet all these beautiful products are available from all the different types of manufacturers in the UK. And the engineers and the sales teams have got all this comprehensive technical knowledge on how these devices can treat highway runoff. And yet the clients and the owners of the highway assets aren't investing in treatment of highway runoff.
Do you think there should be a bigger push for more of those treatment devices? Because let's say 25 years ago, you would have had just standard products being made by manufacturer, maybe a little older, but you'd had standard products. Everybody then came along and retrofitted a lot of stuff, and that was how we dealt with control. Now, as you say, we've got all these amazing products that, you know, can treat it at surface, can treat it below ground, can do whatever we need to do. They just screams at me, as you said, about future-proofing and capacity. They just seems to me, it screams at me that there's a need to be a bit more cogent about that right now and future-proof what is coming, because highways runoff is a, you read about it.
We've got a big problem though, because if you take a bottle of runoff from a motorway, it contains illegal levels of some priority hazardous substances. To treat it to a point that it satisfies the standards is really expensive. We're talking about £2-3 million for a treatment scheme. Alternatively, you could spend £150,000 and do a bit of treatment and deliver a betterment and a reduction of pollution. And so the big question is, do you spend 150 grand at 25,000 outfalls and reduce the pollution to an extent which gives us some breathing space? Or do you wait until you've got £3 million to spend at each outfall to fully reduce pollution to a satisfactory level legally? And I don't know. I mean, part of me thinks we've got 25,000 outfalls off our motorway infrastructure in the UK. Part of me just wants to put a vortex grit separator on every one of those in the next 10 years to reduce pollution by 30 or 40%. But that still wouldn't comply with the law. So we're in a really tricky place, but just do something. Please just do anything.
I think this is a big problem in policy around emerging contaminants and not even emerging ones, standard contaminants. It's inertia. It's this. Well, we need more information, and at some point a decision does have to be made. And I think that there is a real misunderstanding around the science, in the sense that if you don't know everything 100%, that doesn't mean you don't have to act, because you'll never know everything to 100%. If you work in a university, you're well aware of that. It's about understanding, at this moment, what's the best solution that we can, and what can we do, and actually working off that, because I think that there is this real fear, oh no, but what if we do it wrong? Well, maybe we'll get it wrong once or twice, but we'll also get it right a lot of the time, and overall there will be a huge benefit. And it's just allowing, I think, our policy people and those people making those decisions, either in government or a national agency level, empowering them to make those decisions, so that they don't feel that if I make this decision now, in a year, if the concentration hasn't come down, what does that mean for me? And I feel we need to sort of back off that slightly and say, okay, so long as we know you're doing the absolute best you can with the best data that's available to date, I don't see how we can then penalise people.
Isn't it really interesting? There's a similarity in the logic there between how in the last 10 years things like whole life carbon and life cycle analysis has followed very much a similar vein of being quite scared of
Don't
doing
want to
them.
admit to anything to start with.
Worrying them because, hold on, I'm doing an LCA for this, but I don't have 100% of the constants there. Well, look, you have 80% of them. The 80-20 rule applied. You have 80% of the constants. Go work out that. Look at that. One of the interesting pieces that we want to look at is what the whole life carbon over pipeline is. We talked about it a couple of times. Okay, I can't get every constant, but I can at least get enough of the constant to understand and be able to look at what, as you say, almost be fearless in it, look at it and go with 80%. If you've got that information, model it, start doing it, and then iteratively, in the end, you will get to the 100%. But it's very interesting that it's the same mindset there of being afraid of reacting to something because you don't have 100% of the information in front of you, but you've got enough. The scary thing is you've got enough if you think about it in a...
But that's when Nicole comes in, because it's monitoring, it's measuring, isn't it? We've got to measure it.
But it's often sometimes it's the relative data you're interested in, it's the relative comparison. It's not the absolute values that you get everything, as you say, everything 100%. But if you compare different ways of doing it, and you do the same approach, then at least you get a relative comparison, even though the absolute values might not be 100% correct, because we just don't know it. So,
yeah, but if you can understand that, this product will remove 50%, but it will cost X amount, and this product will remove 100%, but we're, let's face it, never going to be able to roll that out nationally. Then you can start to make some of those comparisons more sensibly. And there's also just being fearless about where are you trying to protect?
Yeah.
You don't have to do it across the whole world, the whole country immediately. I mean, it'd be lovely if they did, but where are your danger areas, and understanding those sorts of things. And again, I think that's where the universities all come in. We have all of that kind of data. So working with industry, and that's where I think the universities are really useful.
But what we've got to fix is that because we've known for 40 years that highway are not polluting, but we still haven't got a policy change. We've got to get better at translating academic research outputs into policy, because we're rubbish at that.
It's one of the challenges for us. We've invested quite heavily on behalf of the members in looking at this research. We want to work on bedding classes. We want to understand contaminant elements and pollution elements of everything, not just that. We want to understand on behalf of the industry that we're in. It's then working to change the standards outside of that. It's why someone, for example, like highways or national rates, someone like that would be great to have that flexibility to take the first step. We want to get rid of virgin materials. We want to get rid of bedding around it and change the bedding classes if we can, because we know it has economic and carbon impact. We need somebody that's flexible that can take that first step to implement that.
I think a combination of academia and industry, though, is very powerful.
Well, for sure.
Because when somebody is approached by industry, sometimes they're like, well, is it greenwashing? Is it this? That there are a lot of concerns. And if they're approached by academia, honestly, most of the time they're like, well, where's the economic incentive for me to do anything at all? So it's that combination, I think, that can be really helpful.
I think that was one of the most satisfying things I saw when we had the email before Christmas from IAA. Very first words were sort of clear economic impact, clear industry support.
no, absolutely. I mean, I think, as you say, having the combination of academia, industry bodies industry bodies are sometimes almost more powerful than individual companies, because they are more holistic rather than just advocating one company. So you get the sector, and then potentially looking at standards. So this is where sort of John comes in, and really having that follow through, or whether it's policymakers or whether it is standards, but having that follow through and really trying to make a change that's impactful for the industry, but it's actually also impactful for academia, because we also have to show that our research makes impact, and that is one route, one way of doing it. And as you say, the reason why we got this particular funding to look at the bedding factor is through something called an impact acceleration account, and it's in the name, it's accelerating the impact or so. And this is working with the MPA was the way that we secured that internal funding that comes from government through the research councils, because we had a clear route of, it wasn't just research, but the output of that research had a clear route into potential standards.
And that's the final nail in the coffin for us, is someone like yourselves not just endorsing that. We would want to go off and do this research anyway. It's the fact of, can we have an impact with that research? There's no point doing it for the sake of doing it. Does it have an effect on anything? When you've got somebody like John that can take a look at it and say, well, yes, this is working. There is a clear impetus for doing this, and it will have some effect. Then that makes the work not just self-serving, it makes it impactful, like you say, for what we wanted to do.
I think it's interesting though, because it's also actual figures that you're getting at the end, or at least good figures. I think your challenge is more theoretical sort of improvements that's harder to sell and harder to advocate.
It's interesting because I know you said there's a difficulty perhaps with the clients, but we've been speaking to a number of people, and it is definitely client driven, that they want to see that environmental, they want to have something on there that's saying that it's good for the environment. It doesn't necessarily have to be good for the environment, because that's very rare. But it has to be better for the environment, or an improvement. And I think actually, I've been speaking to DEFRA and the EA, and there is a move now towards, instead of saying we need to get it to 1 part per billion, we are going to reduce this by 30%.
Yeah.
Because we have to start somewhere, and we're just nowhere near getting it down to that level. So as you've just said, it is that bringing it down slowly but surely. If you bring it down 30% in 5 years, hopefully industry will say, oh, okay, there's a market here, and that gives everybody that impetus to keep moving forward. And in 3 years' time, you say, okay, we brought it down 30%, can we bring it down another 50? And slowly you get there. And I think that at the moment, on our side, on the pollution side, is very much driven by most companies wanting to have something on their website saying, we are doing good for the environment.
So what I would like to ask before we conclude this session is if in going around, starting with John, is if one thing could change tomorrow, because it sounds like from that last bit, we need industry, academia and policy to almost become a triumvirate, step up together and affect this. What, if you could change anything overnight, would you change about the way we do things now?
Well, I think there's quite a lot of knowledge, for example, about buried pipe design, but it does take an awful long time to change mindsets in the industry. It's extraordinary. I mean, it really is true that the only person who likes to change is a wet baby. And I mean, it's extraordinary when you think how, well, I've been involved in buried pipe research now for 48 years. That's quite a long time. And already, 42 or 43 years ago, we had a complete new design system, which has only found its way into the standards now in the last 5 years. But so the industry moves slowly, but I think some of these environmental issues could provide, and the whole carbon debate and climate change, hopefully will provide the impetus to see that transition going more quickly. I don't know what it is. There's just a sort of inertia in the industry. As we talked today of, perhaps it's at the client level, perhaps it's at the consultant. Everyone likes to sort of, as it were, just people. I mean, engineers are naturally risk averse, but we do actually have to sort of take the knowledge and apply it. And I don't know what the solution for that is, but I think that's an area that needs to be improved.
Nicole?
Yeah, I think for me it's data. Maybe being in academics, data is always something that I find really useful. It's either sensors on existing assets or as we lay assets so that we can actually monitor it. So while we are risk averse, we can maybe be slightly more, have a bigger appetite to risk because we are monitoring it. It works in other industries. So if you look at some tunnel construction, you look at the new Austrian tunneling method, because it observes, it monitors, or so your lining, also often mainly concrete, is quite thin. So the wall, tunnel wall is quite thin. So I think having data, having sensors, obviously being quite selfish, thinking we have a national facility in the UK now, which allows us to do large-scale tests. So we don't have to scale things down, so we can actually look at the influence of the soil structure to action much better than if we're trying to reduce it. We're much more affected by boundary conditions, so I think that is those are the things. But as we all say, I think it's that combination of having academia, industry, and policymakers, or standard committees all working together to really make a change.
Fantastic. Steve?
There's always two really straightforward answers we sort of give here. Is sort of right product for the right, people starting to make good decisions on that, especially based on resilience and what the long-term implication of. But there's the other side of that, which is, it'll be really incredibly interesting to see what the members do when these challenges come up. We talked a lot about how the infrastructure will have to cope with pollutants or longevity or other impacts of climate change and things like that. It'll be amazing to see what the members, because they always react to everything. The reason the industry is here and it's stuck around, it has an incredible legacy, is we always react to what is needed coming down the pipeline. And with some of the challenges, we've already faced some that we talked about, products that have changed over the last however many years. It'll be incredible to see what they change again, what the next line of product is, or to reiterate what these products are, because there's challenges coming and they will have answers to them that bleed out into industry, and it'll be good to see how we can push on and maybe help some of the standards change to challenge some of those. Very interesting time to be involved.
John? I'm going to come back to what I started with, I think, which is proportionate and consistent regulatory control of partly of pollution discharges and product installation, but also product declarations as well, so that as this market expands, we see good manufacturers moving into that space with honest and transparent declarations about the function of their products, and then regulators making those products go out and be installed to protect the environment.
I think it's the longevity mindset. So there is an understanding, obviously, within this particular group about longevity of the pipe or the asset. But I'm talking about looking long term at future scenarios and really thinking about those across the whole sector, and not just within the industry, but within policy and within academics. So we're not trying to fix a short-term solution. The environment is there forever. We need to we need to think of that kind of time scale.
So consistency to engineers, designers, but not just overnight give them consistency, but have the tools to be able to have confidence to give consistency for approvers. But then to contradict slightly is to actually give engineers and designers the power to question a norm, but that comes from consistency. So if you know where you're starting from, it's easier to challenge where you need to be or where you want to give younger engineers really that confidence to have that knowledge sharing, but then to actually ask the questions. And just because we've always done this doesn't mean we always have to do it. So.
It seems that there's a lot of actually positivity and optimism as well, which surprised me coming through. But I would say, as Harold Wilson once said, for those who can remember him, I'm an optimist, but an optimist that wears a raincoat. It seems that there needs to be a lot of work done now in order to affect this positive change as well. And one thing that came really clear, and coming back to it, was that we need to get the industry, policymakers and academia on board working together to develop actually nuanced solutions rather than thinking of a one-size-fits-all one as well.